3x to the fourth. Okay, now, I'm going to write this over here because this actually affects the answer, but we'll talk about what my expectations are for you. All right. Let's say you want to use your calculator to solve this. Okay, so the first thing you would do is replace the x and the y. Okay, and so we could ask our calculator to solve for y in this calculation. Just, again, inverse, you just invert the letters, x and y, solve for y. So if we took our solve feature, x equals 3y to the fourth, solve for y, and answer. And now notice that you get, there's this or, there's two possible answers here. Okay. All right, when you look at this, the first answer that you're going to get will most likely be the solution when x's are positive. Okay. So when the actual x's themselves. Now, this answer is in terms of the other variable. So you can disregard this because these are both saying and x is greater than or equal to 0. So the first number is if the original domain was positive. The second number will very likely be when it's negative. But I'm going to kind of talk about that here in just a minute. But right now, here's what your calculator shows. Okay, so I just talked about ways to interpret this information. So here you know that your inverse function is going to equal 3 to the 3/4 times x to the 1/4 over 3. Well, that doesn't necessarily help you when I ask you to write it in radical form, right? So what I had mentioned in that, you need to make sure, in order to combine all of these, you need to have the rational powers be exactly the same. Okay, so if you look in the numerator here, they both have fourths, so we're good on that. But we need to somehow figure out how to get this first factor into 1/4, a power of 1/4. Well, remember, the properties of powers is you can apply the power to a power rule. You can take the index and the power separately. So if we cube the 3 and then apply that radical, the fourth root, or the power of 1/4, we can now put it or imagine it in this form where they have the exact same powers. So you can reduce this down. 3 cubed is 27. So really you're looking at 27 to the 1/4 times x to the 1/4 over 3. And since those are in the same index, which represents the radical or the nth root of fourth root, you can just put the 27 and the x inside there. Okay, so here's what you would think the answer is. Now I changed it so that it accepts this as the correct answer. So I mean, if you entered this, you should be okay now. But because this original problem wanted to identify, remember when I broke the graph in half and I said the left half and the right half here? Normally you choose the right half. The right half would be x is greater than or equal to 0, yes? All these x's here. Well, in this case, they wanted you to choose the left half because they asked for x is less than or equal to 0. So what that winds up being, and you can kind of see it in this graph here, instead of it being this upper portion, and the next section that we're going to talk about, we'll talk more about reflections and transformations. But instead of it being this upper part, this square root of x, if we had asked to just look at this portion here to the left, then we're going to be dealing with this as the inverse. Well, the way that these differ is this bottom one, if that was our answer, would be you'd have to multiply the whole thing, everything out front, by a negative. That by multiplying the front by a negative, it actually reflects it across this horizontal line. Okay, and so what that tells you in this, again, I'm not going to require you to do this on any questions I give you on quizzes, but since we're looking at the values that are to the left of the origin, you need to put a minus in front of this. So this is why if you got an answer, it didn't show up, there should be a negative in front of this. And now let me go back and talk really quickly because I think there might be a couple other questions. In this section, you do not have to rationalize the denominator. Okay, so what that means is solving this problem by hand would probably be easier because the solution by hand would be, again, replace the x and the y. And then just solve for y. So to solve for y here, we're going to divide by 3. We're then going to extract the fourth root by taking both sides to the fourth root. And so you get your inverse to be the fourth root of x over 3. Okay, so this right here, and again, in this particular case, because they're asking you to find the ones to the left of the origin, you'd have to put a negative here. But I changed this question so it would accept either answer, positive or negative. But if you just leave it in this form without having to go through and rationalize the denominator, you're done. Okay. And so that'll be true of a couple other problems. Any of the problems that have the square roots, cube roots, you should be able to just enter the problem, even if there's a number in the denominator. You do not have to rationalize it.